The next phase we're going to go into is to create our first enemies. So we need our enemies in the game to damage the player. We need them to follow the player. But in this particular one, we're just going to create the first enemy and make him kind of follow you around. So let's dive straight into that. As before with the player, in the models folder, in characters, you will find there are some models. One of those models is this lovingly created Zom bunny, which looks something like this. And what we're going to do with that is to place him directly into the scene and then start working with him in a similar way that we did with the player. So as usual, I'm just going to quickly hit save, just so I don't lose any work if we get a crash. And then I'm going to drag my scene view around. And this bit really doesn't matter where we place him because we're going to spawn him later on. But I'm going to use dragging from the project window, and you can see that it snaps to the environment or whatever I happen to place him onto. I'm just going to drop him near the player, somewhere like that. Then when we shoot this bunny, we're going to have stuffing kind of fly out of him. So we've created for you a particle system to do just that. In the prefabs folder, you will find a hit particles prefab. So like we said before, prefab's a way of storing something that you've already set up, and we did exactly the same thing. We've created this hit particles. And what we need to do is apply this to the Zom bunny. So in Unity, all game objects that you put in can have a hierarchy. So the Zom bunny has a child object, which is its mesh, its kind of outline, but it also has a parent, and we want to drag drop this particle system on so that it's attached to the parent. So what I'm going to do is select my Zom bunny, and I'm going to drag and drop hit particles onto the parent Zom bunny, so that when we expand it, we've got Zom bunny, the actual object itself, and hit particles. And basically all this is doing, if I select my hit particles now, is creating this little puff of stuffing. So I can see that because I've got that game object selected, the scene view shows me the particle effect overlay, and you can see it's creating a puff of fluff that's coming out of him. This particle system, we didn't want to get bogged down too much with these various settings, but we're basically using a texture which is applied to this to just fire out a little emission of those. Again, we want to detect whether this is something that we can shoot at. So similar to how we detected whether we can turn to face a particular way by isolating the floor onto a floor layer, this Zom bunny is going to be on a shootable layer. So with the Zom bunny parent selected, so make sure you reselect the parent, go to layer at the top of the inspector and choose shootable. Okay, so set that to shootable, and then it's going to ask you if you would like to change the children. So basically all this is saying is, do you want them all to be on the same layer? The child objects say yes, change the children.
A quick note, the environment that you all dragged into the scene at the start is also on the shootable layer, so that means that when we later give the player a working gun, you can hit the environment as well.
We've done that, and then we basically want to set up the Zom bunny in a similar way to the player. So we want him to have physics, we want him to have a physical presence in the world, so we're going to do some of the similar things that we did before. The first one of those I'm going to do is to add a rigid body component. So just to give you a different way of doing things, we previously used the menu, but you'll notice that this is actually a search field. So I'm just going to type in rig, and I go straight to rigid body. I can hit return to add that. I'm just going to make that expanded so that I can apply some settings. Again, drag and angular drag should be set to infinity. So I'm going to type in INF, hit return, and it should change to capitalized infinity. And the constraints are exactly the same. We want them to be able to rotate only in the y-axis. We want them to only be moving in x and z, frozen position y. So your constraints should look like this. Freeze position y, freeze rotation x and z. In order to actually give this physics object a boundary, we're going to put in a capsule collider, so the outline of its physical shape. So I'm hitting add component one more time, and then I'm going to type in cap for capsule collider, and the settings for it are center value of y 0.8 and a height of 1.5. 0.5. So it should look like this. We need this character to attack the player. So this bit's going to be slightly different to how the player was set up. So the capsule collider is there to give this character a physical presence. But what we want to do is to give him the ability to detect the player. So we're going to use one more collider to do that. And we're going to use a trigger collider for this purpose. So we're going to add component one more time. And we're going to say SPH sphere collider. Hit return. You can also go to, of course, add component physics sphere collider. But that's just a short way of doing that. So a trigger is something that doesn't have a physical presence. It's a collider, which means you can check when something's intersecting it, but it doesn't have a physical presence. So we can just walk straight through this thing. So we check the is trigger box. And then if we just have a look back at our bunny very briefly in the same window, you can see that by default it's set at the origin of this, which is at its feet. So we're going to set the center Y to 0.8 and the radius also, for simplicity, to 0.8. So what you'll see is that if I just expand my capsule collider again, it's slightly further out than the capsule collider is. The reason being that we want to detect the player within the bunny's reach kind of thing. So we want it to bump into stuff, but we want its reach to be able to harm the player. So we make that sphere collider slightly bigger. We make it a trigger so that it's not actually going to bump into anything. That's how we're going to detect the player.
Yeah, so with triggers, the actual interactions within the scene is not what we use a trigger for. More importantly, a trigger, when anything collides with a trigger or goes into a trigger, a function is called if you have a script attached that says, hey, something touched that trigger, right? And that's when we write our individualized code that'll be like, okay, something touched that trigger, right? So its interactions in the scene view are not what we're interested in. We're actually interested in the behind-the-scenes interaction we get to write with our own code.
And finally, the last thing we're going to do to complete the Zombunny is just to add an audio source. So I'm going to type in audio, I'm going to scroll down. I can use my arrow keys in this add component menu. And I'm going to use return to choose audio source. So this thing is just to allow him to make a sound when he gets hurt. And we're going to make that the default sound clip as well. So as before, using circle select, I can just click and choose Zombunny hurt. It's the very bottom one from the list. I can double click it to assign and close the window. As before, we don't want it to make the sound, so we're going to uncheck play on awake. We obviously don't want that to loop or anything, so we're going to leave that there. Next, we need to make the guy actually follow the player. So in Unity, there's a system called navmesh. So in Unity, window navigation is what you need. Window navigation. That should automatically dock itself next to the inspector. If it doesn't, that's a great place to put it. So drag and drop that tab next to the inspector on the right of your interface. We're going to reselect the Zombunny and go back to the inspector. The navigation panel is there for us to set up our level. We're going to set up our Zombunny first, and then we're going to go back and set up the level. So with our Zombunny selected, I'm just going to close some of these by collapsing them up, give us more space to look at. I'm going to add something called a navmesh agent. So like I said, there's a system called navmesh, which is used for simple AI in Unity. And basically what it means is you can do a process called baking, which is to specify which parts of the level are navigable. And then you have something called an agent, which is something that's going to traverse that or move over that environment. So the Zombunny is something that's going to do that. So we are going to give it a navmesh agent component. You can see that it has an outline here, similar to a collider. And we're going to set a more appropriate radius than the default of 0.3. So 0.3 in radius. We're going to set the speed to 3 by default and stopping distance to 1.3. And we're going to set the height, which is slightly lower down, to 1.1. So because it's easier to see these settings on the PowerPoint, I'm just going to switch over to that. So we've added a navmesh component. The radius is 0.3. The speed is 3. Stopping distance is 1.3. And height, a few properties down, is 1.1. It should look like what we have in Unity.
If you recall for the player, we're moving the player using physics, right? We're not doing that with the bunnies themselves. The nav mesh agent is actually what is moving. So just keep that in mind. We're not actually going to be using forces with the bunnies. Instead, the nav mesh agent is going to pick and follow the target automatically while also avoiding obstacles and things like that. And that's what Will meant when he was talking about AI. It's this AI pathfinding.
What I wanted to point out as well is, and you guys don't need to do this at all, so if you could just watch for a second, the environment is already prefabbed. We put colliders onto everything, so you can see that the player can bump into all of these objects. We used primitive colliders for performance reasons to make it all work nice and neatly. What you should also note about that is that there's a checkbox up at the top here called static. That's checked, and that means that navigation static is also checked. So what that means is that all of the things that we've specified in here as being a navigable space are going to be included when we bake the nav mesh, when we create this navigable area. So what I want you guys to do now is to go to that navigation window again, and we're going to switch over to the bake tab, so the middle one of the three. And then we have some settings that we're going to put in there.
The radius of the nav mesh is approximately how near to a wall an agent can move. So we're going to have multiple types of enemy in this. So we've got some zombunnies, some zombears, and some elephants. Now, elephants are a lot bigger, so we need to compromise with the radius of the nav mesh. Normally, you'd want to have nav mesh agents and nav meshes with the same radius. But since we've got different size agents, we're going to compromise and make the radius for it
0.75.
Likewise, this height is a compromise. We have zombunnies, which we made 1.1 in height. The elephants are going to be a lot bigger, but we're going to make our height a compromise between the two. We're going to give it 1.2. But normally, if you've got one type of agent and they're all the same, give the radius same as the nav mesh agent and the height the same as the nav mesh agent.
Cool.
So the next thing we're going to change is the step height. So your nav mesh agent can go up steps, and because our floor is uneven, it's made up of floorboards that are sort of sticking up a little bit like that, we need the nav mesh agents to not go like, oh, I can't get over that floorboard, I better go around it. So we need a very small step height to make sure that it can get up over those bumps.
Then we're expanding the advanced area, and we're setting the width inaccuracy to just 1%. So drag that width inaccuracy down to 1.
So the width inaccuracy affects how carefully the nav mesh is baked. A nav mesh can be baked very quickly if you give it high inaccuracies, and it'll look quite angular and it'll be quite approximate to your environment. But we want it to be a very accurate nav mesh. So this is going to take a little while to bake, but we'll end up with a very nice nav mesh afterwards.
So once that's done, you are hitting bake at the bottom of the window. And what you'll see in the scene view, once it's completed that process, is that you'll see a blue overlay on the entire level. So you'll get a progress bar at the bottom. It says exporting tiles like this. Once it's done that process, you will see an overlay in the scene view as long as you are on the navigation window. And it should look something like this.
So what's happening here, by the way, is agents in pathfinding and all that will work with complex meshes. However, it's incredibly inefficient, right? And you're going to have all sorts of issues if there's bumps and cracks and things like that. Basically saying that while you can traverse these unusually sized and shaped meshes, it's really not worth it, right? You generally want your movement to be smooth, and you don't want it to be that inefficient. When we bake a nav mesh, what it's doing is it's finding all of the static meshes in our scene, things that are marked as navigationally static, and saying, these aren't going to move, these are going to be things that we can walk on. And it's going to calculate a very simple, flat mesh and go, it's not exact, but it's close enough and no one will ever know. So it's much more efficient, and it actually makes it much more accurate as far as actually moving around how you would expect things to move around. So that's what we're doing. We're actually on the fly. Unity is generating a new mesh, which is just a flat plane, possibly with a slope to it or whatever, but it's very simplified, and it makes the actual AI process of navigating very simple.
Just to make this very clear, these things in our scene are marked as static. So if we wanted to move our blocks at some point, we'd change the design of the game, we would move them and we would rebake the nav mesh to recalculate that traversable area. Okay, so we need this character to run around and chase the player, so we're going to apply animation to this. What we want to do is to select the animation folder in the project panel. I'm going to click the Create button, and I'm going to choose Animator Controller. So select the animation folder, choose Create Animator Controller. This one is going to be Enemy AC. AC short for Animator Controller. And then we're going to assign this to our Zombunny. So the Zombunny, if we drag and drop that asset onto it, it will assign it for us. But just to be clear, what we're actually doing is assigning this to the controller property of the animator. So either drag and drop to that component, or simply drag and drop straight onto that object to automatically assign it for you. So when you select the Zombunny, you should have Animator Enemy AC as the asset. So that is a animator controller, a state machine. So I'm going to double click Enemy AC to open it in the animator window. We should have an empty new state machine to add animations to, just like we did with the player. As before with the player, the animation for the Zombunny is stored within its model. So I'm going to expand the model and go to the characters folder in the project. So in the project panel, open up models and select character. And then expand the Zombunny, and you will see that and its animations. The Zombunny has move, idle, and death, and they are clips that are on a particular point in the timeline. You can see as I go between these clips, they're all in a different part of the timeline, as you can see from here. The way that we can do that when you bring in an FBX model that you've animated is you can just create new clips, and you can tell it what frame range you animated them on, and Unity will import those for you as different clips. And just like the player, they appear underneath that in the hierarchy. So you have death, idle, move. Just as before, I'm going to drag them in. I want the default state to be moving. So I'm going to drag that one in first because that gets made the default. Default signified by orange. Then I'm going to drag in the other two, idle and death even. I'm going to put death next to the any state, and I'm going to put idle and move together. Again, the position of these is kind of irrelevant, but I like to have things nice and neat. Once those are in there, we've positioned them nicely, we're going to create parameters for them. So making sure that move is the default, so set as default with right click if you haven't already. We're going to create parameters. We have just two parameters for this one. And as before, we're going to click the plus icon, and we're going to select the type of parameter that we want. So we want a trigger parameter called player dead. These enemy characters are going to walk, they're going to have their moving animation until the player dies, and then they're going to go into their idle animation. Then we're going to create another trigger which says that they themselves are dead, which is just called dead. So two trigger parameters, player dead so that they can go to idle when you get killed, and dead themselves so that they can animate into their death animation. Then, of course, we need to actually control the logic of this state machine. We want our move to transition to idle. So I'm going to right-click, make transition, and again I get the transition handle. I'm going to click on idle to assign it. I will select the transition by clicking on it. Once that transition is highlighted in blue, I should have my list of transitions. So in order to go from move to idle, the condition is that the player is dead. Then, very simply, in order to go from the any state, I will make a transition, click on death, select that transition. The condition for that is that the dead trigger has occurred. So if I just scrub through, you can see we go from moving into death.
You've also noticed that you can't go from idle back to move, because at that point the player's dead.
So we have no need to create a transition back. These state machines don't work by themselves. The connection between the state machine, the animator, and the actual functionality is that the scripting needs to tell those parameters what their value is. So we need a script to say that the animator set trigger, player dead, will actually happen. Otherwise, the animator does nothing by itself. In the scripts folder in your project, you will see a folder called enemy. So go to scripts folder and open the folder enemy. And in that, you'll see a folder called enemy movement. We're going to drag and drop that onto Zombunny in the hierarchy. And then once you've assigned it, either double-click enemy movements icon or go to the cog icon and go to edit script. But basically, we're opening that for editing. And when you open it for editing, it should look like this. So what you'll notice here is that we have a script that's been ready written for you. Some of the functionality has been disabled. You'll notice the double / symbols at the start of some of these lines. That's commenting. So you can write comments in the script, i.e. just notes to yourself or to co-workers, whatever. But you can also use that to turn functional lines of code into deactivated lines of code. So that's what we've done here. And we're going to come back to this script at some point and enable some of that functionality. But for now, we're just going to explain how this script functions.
This is our enemy movement script, and at the very beginning we have this transform player, and the transform player is going to be what the enemy is going to move towards. You will notice the transform player is not public. With the camera, we had that public transform target, right? So we could click and drag in the editor and the camera knows what it's following. However, our enemies are not going to be in the game when the game starts, right? Our enemies are actually going to be what's called instantiated or spawned later, so whole hordes of them can appear. As such, we can't just click and drag the player onto them. So what's going to happen is they're going to have to find the player on their own. So for now, that's just transform player, no public. We also have a reference to a nav mesh agent, which is the component we put on the Zombunny previously. This is just our reference to it, which we've called nav. Now down in the awake method here, we are, first off, we are finding the player. Okay, so we have player, which is that transform before, player equals game object dot find game object with tag. So if you remember previously when we were setting up the player, we gave the player the tag player. So now that we've set the player with the tag player, we can find that player using this function. So basically what it's going to do is it's going to go through all of the game objects in our scene. It's going to say, hey, do you have that tag? Do you have that tag? You know, so on and so forth, until it finds the one and it gives it back. And then what we're going to do is we're going to say dot transform, which is going to give us a reference to the transform of the player. So basically where the player is. So we're storing that in our variable named player. Next, we have a variable named nav, and we're just setting that equal to get component nav mesh agent, which is basically going to pull a reference to the component we have in the editor. All right, so at this point, we're just setting up. Then down in our update function, you'll notice we're using update, not fixed update. As this is a nav mesh agent, it's not keeping in time with physics, so we're just going to use the regular update. And inside there, we are going to say nav.setDestination player.position, and that's it. So nav being the nav mesh agent, we're saying, hey, that's where I want to go. Where do you want to go? I want to go towards the player. And that's it. And the nav mesh agent goes, cool, I'm going to head towards the player. And the nice thing about doing it this way is that the enemies aren't going to bump into each other, right? They're not going to crop in and out of each other. They're going to move around all the creepy baby arms and Legos and weirdness that we have in the scene there. And they're going to viciously and unerringly attack you with extreme prejudice and violence. The nav mesh agent makes it very easy to do these things.
Yep.
And that's the whole script. We'll revisit this script later when we want to uncomment and re-add in that functionality that you see is currently grayed out.
So we can switch back to the Unity editor right now. We don't need to save anything because we haven't actually edited it. But I do want you to make sure that you have applied it to the player. So the Zombunny in the hierarchy should have the enemy movement script attached to it. I'm going to save my scene, and I'm going to press play to test my game. When you press play, it now follows the player. We don't have any coding for attacking yet, or anything like that. So it's not going to do any harm to you. You can just kind of walk around and kind of push him around. That is the end of phase 4.